When we have inequality word problems, we're looking for phrases like at least, at most, maximum, minimum, no more than, no less than. That's going to tell us that we're not going to be writing an equation with an equal sign, but we're going to be writing an inequality. So let's see how these play out in a word problem. Um, Emma got a new job and will have to move. Her monthly income will be $5,270. Must be nice. To qualify to rent an apartment, she has to earn at least three times as much as the rent. What is the highest rent she will qualify for? So, her monthly income, $5,270, has to be at least, it could be greater, right? But it has to be at least three times the rent. So we're going to go through here and solve for r or x or whatever value you chose to use. We're going to divide by 3 on both sides. When we do that, we get $1,756.67. And that is greater than or equal to the rent. So the rent she can pay, according to this formula, is she can pay at most $1,756.67 for rent. She can't pay any more than that. Like that's the cap, right? So rent is not normally paid for in pennies per month, right? So let's put this to the nearest dollar, the nearest ones place. We're going to round it. Be careful. Normally, if we just had this number and we were rounding it to the ones place, we would look at the tenths. It's bigger than 5 or bigger, that is. So we would round it up. But this sentence says R is less than or equal to this number. So we cannot round this up. We have to only round it down because our rent has to be no more than that number, right? So if we were rounding it to the nearest dollar, we're going to round it down because she can't pay more than $1,756.67. She can't even pay one more penny over that, 68 cents, right? So we have to round this guy down against the normal rules of rounding because it's an inequality. You all right there? We're going to do more of that, so stick with me. Angie has $20 to spend on juice boxes for her son's preschool picnic. Each box costs $2.63. How many packs can she, sorry, each pack of boxes, how many packs can she get? So she has $20. That's the cap. She has no more than $20. That is the highest amount, right? That's the bigger number. And we are going to spend $2.63 per each pack we get. We're going to try to get x all by itself here by dividing by 263 on both sides. When we do that, we are going to get 7.605. Well, there's more. I'm rounding. Is greater than or equal to x. So again, if we just had the number 7.6 and we were rounding to nearest number of packs of juice boxes, right? We can't buy 0.6 of a juice box. We would round this to 8 normally if it was just a number, but it is not. It's an inequality. So x has to be less than or equal to 7.605. We cannot round this up to 8. We have to round it down to 7 packs of juice boxes. Yeah, maybe. All right, Tiffany just graduated from college, and her new job is going to pay her $20K a year plus 3% of all her sales. And she wants to earn, oh, Tiffany, what a goal. She wants to earn at least $100,000 a year. Good for you, girl. What total sales will she, for what total sales will she be able to achieve her goal? So we're earning $20,000 plus 3%. You can put that as a decimal or a fraction or just as the percent of all her sales. Like that's how much the dollar value of what she's selling, right? And she wants at least $100,000 per year. She does not mind if she's making more, right? So $100,000 is our like floor. We can go even higher. So that's our greater than. All right. We're going to try to get x all by itself. We're going to subtract 20,000 on both sides. Then we've got, I'm going to change this to a decimal because I think some people really don't like fractions. All of those are, this and this are both representations of 3%, right? Hopefully we know that. All right, we're going to get 80,000. We're going to divide it by 3%. 80, this is saying 80,000 is 3% of what number? And I'm going to tell you right now, it's an enormous number. You have to sell a lot to make an $80,000 commission. X is greater than or equal to, oh boy, 2,666,666.67. A lot of sixes. So in this one, let's read it back to see how we would round it to the nearest whole number. And I mean, she could, I suppose, be selling things that are making her pennies amounts, but let's look at it. It says X is greater than or equal to this number here, right? $2,666,666.67. So since it could be greater than, that's the smallest it could possibly be, we are going to round this guy up. She needs to sell at least, if we're doing to whole, to dollars, $2,666,667. That will get her at least 100,000. That'll get her a little tiny bit over, right? If we round it down to 666, that's going to get her a little under $100,000, and we don't want that for Tiff. We don't want her getting $99,900 this year. We want 100K for her. So we're going to round that guy up because it was at least that much. All right, let's do one more. Malik is planning a 6-day summer vacation trip. He has $840 in savings, and he earns $44 an hour when he's tutoring. The trip is going to cost, oh boy, $525 for airfare, $780 for food and sightseeing, and $95 per night for the hotel. How much does he have to tutor to get enough money to pay for the trip? Okay, we have to do a lot of things here. We're going to figure out the cost of the trip. We're going to look at how much he already has, and that'll tell us how much he needs, and then we'll be able to figure out our tutoring amounts, right? So the trip is going to be $525 for airfare, $780 for food and stuff, and then $95 a night. Notice it's 6 days. I'm going to assume that means 6 nights. It could have been 5 nights, but we're just going to assume 6 days, okay? 6 nights, that is. So we've got 95 times 6 plus 525 and plus 780. Altogether, we've got 1875 is the cost of his trip. He already has 840 saved. Fantastic. Great job, Malik. So we are going to subtract that out, and that tells us he needs to earn $1,035 in order to pay for the trip. Okay, now we can say that he needs at least $1,035. He could have more, right? This is the floor. We can go higher. So that's the smallest. We can go bigger. And he's going to make $44 for every hour that he's tutoring. So now we're going to get X all by itself, dividing by 44 on both sides. And we've got 23.52. It has a bunch more after that. I'm just going to leave it here for now because we're going to round it to the nearest hour. Okay, so if he was able to tutor for 23.52 hours, he would have enough to pay for the trip. But he can't bill for 0.52 hours, right? That's not possible. I mean, maybe he does, but that's not common. So he has to bill that we have to go up to the next hour, the next round or whole number, round to the nearest ones place. Since we're rounding this up, he needs to tutor for at least 24 hours in order to earn enough to pay for the trip. And that's how we do it, because X can be greater than or equal to 24. He could work 25 or 26, right? So in inequalities, you're looking for at least, at most, maximum, minimum, etc. And then you are being careful about rounding. You can never, have 0.6 of a person or of a juice box or whatever. So look at your inequality. If it says your number is greater than or equal to that number, you need to round it up because we need to go more than. If it says X is less than or equal to that number, you always have to round it down because we can't go above it.